Hello everybody, this is Dr. Pennington again, and in this pretty short video I want to talk to you a little bit about how we can predict if ionic compounds are soluble or not. The fact is that most ionic compounds are water soluble to some degree. In fact, all ionic compounds are soluble to some degree, but it's the degree of how much they're soluble that determines whether we can visually see whether they're soluble or not. And so this is a purely qualitative exercise right now based on whether or not our eyes can perceive whether they dissolve or not, whether they're soluble. This is not by any means an exhaustive list, because it only contains a certain number of ions, but for all you need right now, this table should suffice. So what we have in this table are two parts. The first part, and it's important to make sure that you read this properly, compounds containing the following ions are generally soluble. Notice in part 2 it says compounds containing the following ions are generally insoluble. Alright? And then each has exceptions. So there are certain ions, particularly ions of the group 1 alkali metals, and then ammonium, and then nitrate and acetate. All these guys make for soluble compounds in every single case that you can think of. For example, for chloride, bromide, and iodine, they're all soluble with a couple of exceptions: silver, mercury 1+, and lead 2+. And then sulfates are generally soluble apart from with strontium, barium, lead, silver, or calcium. All the others are soluble. So the idea is, if you look for a compound that contains sulfate, let's say you're asked to find the solubility of, say, magnesium sulfate. And you see, well, okay, magnesium is not here. Sulfate, well, it's not there, but sulfate's here. Okay, so sulfate. I know from what this table's telling me, every sulfate's soluble apart from a sulfate that's mixed with this, with this, with this, with this, and with this. And of course, none of those are magnesium. So these are the only ones that are insoluble, so therefore this one must be soluble. Okay. If we were to look at lead nitrate, for example, we always want to go from the top of the table and work our way down. And the first thing we see is that lead isn't here, but nitrate is right here. It says nitrates are soluble, and there's no exceptions. So therefore, without much thought, we can see lead nitrate must be soluble. Now if we try something else of lead, and we try, say, lead chloride. Chloride, there's chloride. Well, it looks like chlorides are generally soluble with the exception of silver. Well, that's okay. Mercury, that's okay. Lead. So that means our lead 2+, which is what we have here, is insoluble. So I'm hoping you guys can see just how we use the table here. Alright. And we always want to make sure that we take into account the second part of the table as well. So if we were to look at something like sodium sulfide, all right. Well, first off, sodium is up here in this part of the table, so that should tell us that it's soluble. If we just want to check, S2- down here is the ion that we have here. It says these guys, sulfides, are generally insoluble, which is true, apart from when we have these as counterions. All right, so Na+ saying this is soluble matches up with this saying Na+ is soluble as well. All right. If we were to look at something like calcium sulfide instead, we'd see calcium's not listed anywhere here. Sulfide is listed here. And because all these are insoluble apart from this, 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 and this, then that means this one must be insoluble. Alright, so I think I've gone through enough examples. What we'll do is we'll just run through a bunch of practice problems and see what you guys think. And I'll be flitting back and forth between this page and this page. Alright, So let me just erase that, get that out of the way, and erase that too. Okay, so let's look at the first one. The first one was silver nitrate. Silver nitrate. Well, it's got a nitrate in it, so therefore there's no exceptions about things being soluble, so therefore that must be soluble. Let's see, Cu copper phosphate. Now phosphate is PO4 3-. The copper here must be copper 2+. So we've got to see if we can find Cu2+ or phosphate in there. And phosphate. Okay. Let's look at the rule for phosphate, because it's not listed anywhere else, nor is copper. We're in the insoluble part of the table. So when phosphate binds with lithium, sodium, potassium, or ammonium, the resulting compound is soluble. But we don't have any of those. We have copper, and copper is not listed under the exceptions here, with the result that copper phosphate must be insoluble. All right. Let's look at the next one. Calcium sulfate. Calcium 2+, SO4 2-. Sulfate. All right. That's right here. It's not listed anywhere else before it. So sulfates are generally soluble, except when they pair with strontium, barium, lead, silver, or calcium. And calcium sulfate was the one that we were asked about. Calcium sulfate is an example of an exception to the soluble rule, so therefore it's insoluble. Insoluble. So the next one was potassium hydroxide. Now this one's pretty simple. K+ is soluble, no exceptions. Alright, just to be sure, because OH- is here as well, and that's the other ion in a compound, hydroxides are generally insoluble, apart from if you get any one of these ions, which potassium is one. So there we have both parts of the table telling us that is soluble. Sodium sulfide we already did, we said that was soluble. Potassium carbonate, K+, CO3 2-. K+ tells us that there should be no exceptions, it should be soluble. Just to be sure, carbonate is down here as well, and carbonate is in the generally insoluble category, apart from when bound with lithium, sodium, potassium, or ammonium. So we have exactly the same thing here. Potassium is one of the exceptions, meaning potassium carbonate should be soluble. K+ here is telling us the same thing, that it should be soluble as well. Alright. Now PbCl2 we just did, but we'll just go over it again. Pb is not listed anywhere. Chloride is here. All chlorides are soluble apart from those bound with silver 1, mercury 1, or lead 2. And we'd mentioned that before. Because of that, because the PbCl2 is an exception to the soluble rule, it means it's insoluble. And then the last one, this is another lead salt. This guy is acetate, so lead 2 acetate. Lithium, sodium, potassium, ammonium, nitrate, acetate. Okay, so acetate here says, well, there are no exceptions for solubility, so all acetate salts are soluble. We don't have lead 2+ anywhere around here, or acetate down here. So that means lead acetate mustn't be not one of the exceptions to the soluble rule, therefore it's soluble. So the point is here, just using the table to figure out the answer to each soluble or insoluble question. You can see it's not that hard. You just need to look at one part of the table. There's no reason not to look at both though, because they should give you the same answer, just to check. And that is how those work. Alright, thank you.